let me just talk a little bit. Again, as was mentioned, I think earlier, those New Horizons, of course, launched back in 2006 on January the 19th, and that's one of the big milestones with all of these things is actually getting this stuff launched and going to where you want to go. But with Pluto, you have to back up a little bit. And, of course, if you go back, it's all about Percival Lowell and the Lowell Observatory and a kid named Clyde Tombaugh who was looking to try to see if there was a planet X out there. And, of course, he was the one that actually found Pluto in 1930. And I put this up here. This is from my collection. Okay, we were talking a little bit about how people get inspired by this. So this was a book that came out in 1957, and I think I got a copy of it about a year later. And this is how I learned about the planets in the solar system. I thought, boy, this stuff is really neat, and I really want to get involved with this stuff. And if you go back to that particular book, there were 2 pages on the outer solar system. There was one that talked about Uranus and Neptune, and then there were about 3 paragraphs that talked about Pluto and about how that it had been discovered by Tombaugh by looking through a lot of photographic plates, of course, of the sky, and that it might or might not be the planet X that everyone else had been looking for that might perturb Neptune's orbit, and that was sort of the end of the solar system, and gee, there might be some more discoveries that would be coming later with that. Well, of course, things were sort of on hold a bit for quite a while, and then Christie, in 1978, accidentally discovered that Pluto has a large moon, Charon. And actually, it's so large that Pluto is practically a binary planetary system. In other words, the mutual center of gravity of the two is actually in the space outside of Pluto itself. And you can also see there's the discovery photograph on the left where that there was this sort of bump that was on the side. It was really the discovery photo, and then a better picture again from an upgraded version of Hubble later on, where you can actually see the separation. And this also goes back to the whole thing about technology and how that as we gradually go, and we've gradually been exploring, the new technology that comes in enables us to do slightly better than we did before. And it's really an integral part of exploration. And so after that, of course, well, then there was the Kuiper belt. And this was sort of the new piece of the solar system that's out there now. One of the things that New Horizons is headed for. And it turns out that the first one of the Kuiper belt objects was actually discovered back in 1992, QB1. And that was found by Dave Jewett and Jane Liu. And Jane Liu is actually an interesting person as well. She was a graduate student at the time and was one of the people as a kid that got out of Vietnam right at the end of the Vietnam War. And then went on to become an astronomer. And they actually were looking for objects out there for something like about 5 years before that they found this one. And that was really the beginning of us starting to understand that there really was this extra population of material out there at the edge of the solar system in addition to the comets. Now, what we know about Pluto, in a way it's a lot, in a way it's not very much. I mean, one of the things that, of course, we've learned how to do, is by looking at spectra of various objects, is to be able to look at their characteristic absorption bands, and that gives us an idea of trying to figure out what might be on the surface of these various bodies. And that's given us some indication about what some of the surface composition might be on Pluto. There's a representation of Pluto and Charon about how large that they are compared to the United States. And then next to that, there's one of the earlier images from Hubble showing what that you could see of Pluto if you took a look at it. And again, certainly it's something, it's not just a point of light, it's not a comet, but you can't tell a lot else. So as we go on out, whoops, went the wrong way. So now one of the things that we were doing also back in the 1980s, of course, is we had the Voyager missions that were going through the outer part of the solar system, and one of the important milestones there was the Voyager 2 flyby through the Neptune system. And one of the things, of course, that's interesting about Neptune is Neptune's large moon Triton, which is in a circular orbit, which sort of makes sense, and it's retrograde, which doesn't make any sense at all. And so that's one of the reasons that people have thought that perhaps that Triton really is a captured Kuiper belt object and perhaps is an analog for Pluto. It's a good question about to what extent that if one had a close-up look at Pluto that it might look a bit like Triton. Triton, of course, has got some interesting features. There's this varied terrain on the two different faces you're looking at here, and you can see these little dark streaks, and apparently these are associated with plumes from cryovolcanoes. So there's something going on that's actually allowing gas to erupt from the surface of Triton and to populate it with a very, very, very thin atmosphere, but at least some gas coming out. And we just had a few close looks because, of course, Voyager 2 was flying by in the same way that New Horizons will be flying by Pluto. Nonetheless, there's a tremendous amount that one can learn from flybys, and it's really a question of the physics that if you want to get the speed up so that you can get out there in a reasonable amount of time, you can't carry the fuel with you to actually slow down, and that's why New Horizons is a flyby mission. Now, Pluto was at perihelion, the closest approach to the Sun, back in 1989. It's been moving away from the Sun ever since then. And on the left-hand side, the Pluto at perihelion party was a party that was thrown at last bout at the University of Colorado at Boulder by none other than Alan Stern. And this was about the same time that I met Alan. And that was on September the 5th at 5 p.m. And the appropriate representations of Pluto in various guises are, of course, there. On the other side, there was a special issue of a scientific journal, the Journal of Geophysical Research, that Alan was actually the editor for that, the guest editor, and it put together a sequence of scientific papers on what that we believed at the time that we knew about Pluto. And again, it was about the time that we had also learned that there's an atmosphere at Pluto. There had been an occultation of a star by Pluto, and typically this gives you an idea of being able to kind of see what other effects that there might be with some of these bodies. Well, the surprising thing is that if you've just got a chunk of rock, as soon as the planet goes in front of the star, well, the starlight just simply drops off. But what happened at Pluto, and here we go, is you can see that there's this gradual decrease, and then there's a bit of a kink, and then it fell on off, and then it came back up gradually. And the fact that this wasn't just a sharp drop-off meant that Pluto actually had an atmosphere, not very much of one, but an atmosphere nonetheless. And again, being out as far as it is from the Sun, there was that real question of, well, who ordered that? It's about 10 microbars of pressure, and that's not very much. We think that there's a hydrodynamic escape of the atmosphere to the surrounding space. And so one of the big questions has been, well, we saw all this at about the time of perihelion, and as Pluto gets further and further away from the Sun, is the atmosphere going to collapse? Is it going to freeze out? By God, we ought to get out there with a spacecraft and take a look at this sooner rather than later as a result. And I should mention, of course, that Pluto orbits the Sun once every 248 years, so we'll be at aphelion with Pluto about a century from now. And then it'll take about 124 years after that to actually get back to perihelion again. So it's sort of an interesting period in history where that we've actually got the wherewithal of trying to actually go out with a spacecraft and taking a look at this object at the same time that there's some interesting things going on with it scientifically because that it's close to the Sun. And, of course, at the time, as Alan is wont to point out, there were a series of stamps put out by the U.S. Postal Service, and I'll say a little bit more about this at the end of the talk. But the best they could come up with for Pluto was not yet explored, and you will notice that this was when U.S. postage was 29 cents. So that kind of places that in historical context as well. Well, again, if you look at what we can see of Pluto from quote unquote from the ground, Hubble, with respect to going out to 30 astronomical units, Hubble might as well be at the ground, although we don't have the atmosphere to worry about. But you can see what it looks like. That's the moon of the Earth at the same resolution. Okay, so this gets back to what you can and can't tell without actually going out and taking a close-up look at these bodies. And of course, what the moon really looks like at about 5 kilometers a pixel, which is the sort of one of the kinds of resolutions that we will be able to see of Pluto when the New Horizons is out there. Really shows the difference in the story that you can tell. So one of the things that was very hard fought on the political side was in the last planetary decadal survey before the one that just came out, was where that one should rank going out to taking a look at Pluto and trying to take a look at the Kuiper belt as well. Again, this is from the perspective of 10 years ago. And that was really one of the things that was necessary at the policy level for us to be able to go ahead and eventually be able to propose and win the New Horizons mission. Now, again, with respect to sort of the overall mission scheme, the launch was in January of 2006. We'll have Pluto and Charon flyby in July of 2015. And then sometime between 2016 and 2020, we'll have the opportunity for seeing hopefully at least one KBO up close, another one of the Kuiper Belt objects. And as like its sort of siblings that are out there in the outer part of the solar wind, there's a possibility of actually using 2 of the instruments on New Horizons in an extended mission, at least out until the power supply dies off, and perhaps to keep operating the spacecraft out till about the year 2030 to be able to take data that's similar to what's being sent back on a daily basis sometimes, most days of the week, from the Voyager spacecraft, which are currently out at over 100 astronomical units from the sun, of course, having been launched back in the late 1970s, but still sending back incredible scientific data. Now, this will give you a little bit of an idea of how big New Horizons is. It's not very big. It's dominated by the communications antenna, which is pretty typical for these things that go out to deep space. And the other thing that really makes it work is the plutonium power supply on board. This is it's an isotope of plutonium, plutonium-238. You can't make bombs out of it. You make bombs out of plutonium-239, and that one little neutron makes all the difference in the world of how that you can make this stuff. And there's a little cutout up at the top of what the plutonium-238 pellet looks like. It actually glows cherry red because it's hot. And that was really the key to making the Voyagers work, to making New Horizons work, to making Cassini work, to making MSL work, to making Galileo work, to making Ulysses work, to making a lot of spacecraft work. And we're about out of this stuff, and one of the big issues that's been ongoing is trying to get back into a mode of production. There's probably less than 30 kilograms of this stuff left in the world right now, and it was about 30 kilograms that was put on board Cassini. So there's not much left, and it has been a big issue for several years now, again, being involved at sort of the nexus between science and technology and policy. And this just gives you an idea of what the power curve looks like. Plutonium-238 decays with about an 89-year half-life, and that's why the Pioneer 10 and 11 spacecraft finally went off the air, and why Voyager 1 and 2 will eventually go off the air, as well as these other spacecraft, because like any other battery, it eventually wears down. It just takes it a bit longer. So this is the New Horizons. This is a set of the New Horizons instruments. There's a list of the science team members that are on board as well. And again, we've all been working on this very hard since some of us since the late 1980s, which is really when Alan really started up what turned into New Horizons. These things always end up taking a long time. Well, this is a sort of a schematic that shows the new solar system. We've been finding these other objects out in the Kuiper belt as well. There's Pluto. Pluto is actually one of the closer ones, but also one of the larger ones. We discovered Eris, which is further out, and that was what started the discussion of, well, what really is a planet? Because at least initially it looked like that Eris was bigger than Pluto, certainly more dense. There's some discussion now about that maybe Eris is not quite as big as Pluto, and I will not get on my soapbox about that one, being a member of the New Horizons team to go to the planet Pluto. But let me just say also that there are other things out there that are equally weird. There's Sedna, of course, and Sedna is one of the really weird things because it actually goes out as far as over 900 astronomical units away from the Earth, and yet it's gravitationally bound to the sun. It's in a strange orbit, and we really don't know where that one came from. There are a lot of these objects out there. What's interesting is that if you look at it on the edge, you can see that most things are sort of in a plane, the plane of the ecliptic, which is defined by the Earth's orbit. But you can see as we get out into these Kuiper belt objects, there's a lot of them that are very far out of the plane as well. And that's a characteristic of a lot of these things that are not so closely bound to the sun. These are some of the best Hubble images of Pluto. All right, and again, they all look pretty smeared, but there's subtle differences, and you can actually put those together. You can look at how that Pluto changes as a result of the phase, and you can see that there really are surface features that are underlying all of this. And at some point, we'll be able to see that with New Horizons. In addition, it's changing as well as it moves away from the sun. These are both pictures that showing the same range of phase angles, and you can see that there really are differences that are going on. So if this is related to what's producing the atmosphere, if it's related to what's perhaps the atmosphere starting to freeze out, putting deposits on the surface, we don't know, but we're going to be learning all about this in 2015. Now, the other thing that's happened with Pluto since our launch is we found out there's other satellites out there as well. Sharon came along, of course, early from Christie. Well, it turns out with a concentrated look at the system, Nix and Hydra were found in 2004, and then just recently that's been joined by P4, which is yet another satellite. So Pluto is not just by itself out there. It really is a system of several things. And again, this is perhaps a better, sorry about the launch movie, but this is a good picture of the launch. Of course, the Atlas V 551 that launched New Horizons toward Pluto actually had the fastest launch speed from the Earth of any satellite that's been launched to date. New Horizons basically crossed the distance going between the Earth and the orbit of the Moon in about 9.5 hours. Okay, so you can compare that with Apollo, where it took 3 days. Now, it turns out that New Horizons, however, is not the fastest object in the solar system, and it won't be because it's having to gradually crawl out of the sun's gravitational well. And so it's continuing to slow down. And by the time we actually get out to Pluto, we'll be traveling about 13 kilometers a second, which is still a pretty good clip. But it turns out that right now Voyager 1 is really the fastest object that we've made that's getting out of the solar system. It's traveling about 16.5 kilometers a second, and that works out to about 3.5 astronomical units per year. And the reason for that is because of the gravity assist to Jupiter and Saturn. Gravity assists make a big difference, and of course New Horizons had one actually at Jupiter on the way out. And that was one of the ways that we picked up speed, and at least one of my embedded movies is working. If you look, this is Jupiter's moon Io, and this is the volcano Tvashtar. And you can see this is actually a looping movie, but we actually caught the eruptions as we went by. And of course, the volcanic eruptions were discovered by Voyager back at the time of those flybys in 1979, and this is why that depending upon your point of view, AO either looks like a rotten orange or a really messed up pizza. And it's because of all the sulfur that's erupted from these volcanoes across the surface. And one of the things, of course, that we did was to be able to conduct a lot of scientific investigations, again, on a flyby basis of Jupiter. But we were able to add a lot of interesting information about some of the things going on with Jupiter's aurora, with its magnetic tail, things that were a different aspect of which we hadn't been able to see from other spacecraft just because of the trajectory of New Horizons. And now just to give you an idea of where that we are right now, actually this is where that we were yesterday, which is when I downloaded these. If you go to the website, you can keep up with all this, but you can see here is Pluto sitting right out here. And we are on our way on out. This is Neptune's orbit. Here's where we're located at the moment. If you look over in the side view, you can see that this tilted orbit at about 17 degrees off the plane of the ecliptic is the orbit of Pluto. So we're getting there. Right now we are at about this was yesterday, about 12 hours ago, almost 23 astronomical units away. If you switch that around, that's almost 3.2 light hours. Okay, so it takes 3.2 hours for a radio signal to get out there. And of course, you can compare that with the distance to the nearest star, the Alpha Centauri system, which is about 4.3 light years. So even on the scale of the solar system going out to Pluto, it's really, really small distances compared to even the things in the near solar neighborhood. We're going to be coming up with the encounter again. There's a lot that will be going on in 2015, and as we come in close, we're going to be getting occultations of the Sun by Charon and by Pluto. We're going to be looking for the atmosphere by looking with a radio science experiment. There's going to be all sorts of mapping that we'll be doing in all sorts of different spectral regimes. We're going to be looking at the particle environment, how that the solar wind may be deflected by Pluto's atmosphere, looking at energetic particles that may be there because of, again, outgassing and charge exchange with the outer part of the solar wind. Lots of things that we sort of know can potentially happen in terms of physical processes from what we saw with Voyager 2 out at Uranus and at Neptune, and the sorts of things that we think may be going out at Pluto. But of course, to really find out what's going on, you got to go out there, and that's why we actually fly these missions. If we could do everything just on the basis of theory alone, we could just go out and buy a lot of armchairs, and that would be the end of that. But it doesn't work that way. And this just gives you an idea. This is the top level of the encounter timeline. It goes down many, many more levels than this. There's been a team of people that have been working on this on and off for several years now, making sure that everything works. Because there's one thing about a flyby mission. If you mess up, you can't go back and do it over again. That's tough. So you got to get it right. And when you say you got to get it right, it means you've really got to get it right. And it's one of the really challenging things about this business. People talk a lot about, well, I don't see why that it costs so much to send these satellites up. And the point is that if you find out that something has not been put together right, something hasn't been soldered appropriately, you're not going to go up with a screwdriver and a soldering iron to fix it. So you check, you double check, you triple check, you double check the triple checks, et cetera, et cetera, et cetera, and then you cross your fingers and hope that you really caught everything, because everything has to work. But one of the real credits, I think, to the American space program is that we've made a lot of things work really well because we've had those dedicated people out there across this country putting all this together. This gives you a little bit of an idea of what Pluto will look like at closest approach in 2015. And just to finish up, I mentioned the thing about the stamp, Pluto not yet explored. So we're trying to work on that, and there is actually a campaign going on right now trying to get the United States Postal Service, while they're still in business, to produce a Pluto stamp. So we're collecting signatures. If you go to the New Horizons website at there is no www. It's pluto.jhupl.edu. If you go there, there's an icon. This is Dan Drutta that was talking with Alan, I think, yesterday on NPR, and it's a concept for a stamp. And we would enjoy to have people join with the campaign to try to get a postal stamp for New Horizons and for the upcoming Pluto encounter. And that's it. Thank you so much.